Hello, my name is Dan Hansen and I'm a Technical Marketing Manager with Cisco's Server, Access and Virtualization Group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or UCS for short. This video, what we're going to show basically is the concept of high availability during any kind of software upgrades. Now, currently in the version 1.4 and later of the Cisco UCS, we actually have broken up the software upgrading process to allow us to have different bundles as shown here for different components. There's the infrastructure bundle that we can just paste in locally off of browse to the file, or have a URL where the file is stored to actually paste that into the system, and it'll upload it in. We have bundles for our B series servers and for our C series rack mounts, all that are managed under UCS Manager. And as we load these up as the first step to doing this upgrade, the real goal of this is to show how this can be done and a way to maximize availability and make more of a routine of any kind of maintenance action in change windows for the customer. This is a process we're using in many of our production customers out there. So the basic idea is, as I run through the system and see the various components and the software versions that are existing and out there, where I'll start with on here is I'll take a look at the build of some of these servers. So here I'm showing the A/B and B/A on a Windows server. And what this really means is I'm defining multiple adapters, but I'm relying on fabric failover for high availability so that these adapters stay up when one of our fabrics, either the A or the B fabric, goes down during an upgrade procedure, during a change window. We do the same thing on the Linux box you saw, and then here for the hypervisor devices, we have the individual A side and B side adapters still, as the hypervisors have built-in technologies to do the failover themselves. When we talk the VMFX, this is showing that it is built in, this fabric failover, to the VMFX technology, and we would also recommend it for Hyper-V type deployments at a customer. So what we'll show also is under the management interfaces in the UCS, we can set up a monitoring policy, and this functions somewhat similarly to some variants of Linux HA, for example. We can have it ping a gateway, ping various targets, check out the status of the media interface, and make actions on where the virtual IP that the UCS high availability cluster lives is actually coming from. So here when I jump on my bare metal server and I ping the outside world, I'll just start a perpetual ping, just that we can refer back to throughout this video as we show the process. I'll do the same thing here on my Linux server. So we'll start a ping back up that we were running for another video and let it go. Now, just to try to achieve some level of completeness here, what we're going to do is jump back and just show two more very common deployment scenarios. One shows this with the VMFX technology. So I'll actually, instead of opening a pair to switch back, I'll just go to the console tab and log into this server. And we'll start the same perpetual ping, and we'll do the same thing on another server up here. This one, however, is tied in through the Nexus 1000V product. Okay, so we have two separate switching infrastructures set up on this vCenter. One is the Nexus 1000, and one is the VMFX technology directly on the UCS Manager. So when I go into each server, I'll again just start the perpetual ping. Same gateway device that we have on this lab network. So as we're jumping back, we'll take a quick look and jump into the actual firmware again, management. Take a look at the firmware that's deployed on this infrastructure, and what we're actually going to be upgrading as part of this process. So the first step that we'll look at here is we have host firmware packages and then something called management firmware packages. Now on the management, what we're looking at here is I just have this package with a given name, and I can construct it with the CIMCs or the management controllers for all our blades and rack mounts in one package. What this allows me to do is take this package, apply it across individual service profiles or templates, and then I could certainly update this by simply renaming the package or create an entirely new package and apply those to given servers. So doing this right now and then correlating with my maintenance policies that I had defined, you'll see right now on my server number 1 is the one that I have it set up to immediately take effect. So it's actually doing an activation right now for the software on this controller. So what we're going to do now, before we worry about the individual blade beyond that, that is, by the way, a non-service impacting, because that's just the management controller to the server. So now I come into the UCS system, and on our I/O modules, the first thing I'll do is update. So updating is just setting the backup firmware for this device again. We're not doing anything that affects service in any way. So as we do this, to show, again, what's been applied, mainly it is just the I/O modules right now that we have as the first step. So we've applied those as a backup version within this window. So now that that's ready to go, and it's taking what is there, the running, the startup, and the backup, and we're ensuring that this is ready for the next step in the upgrade process. As we go into the individual servers, the Windows servers and the Linux devices, the pings are still running, and through the VMs that are on both different switching types, we have the actual traffic flowing through. So with that, we'll jump back and take a look again, and we are ready to actually start some of the activations of this new firmware. So the first thing we'll look at is, again, these I/O modules within a chassis, and we don't have to do this in the rack mount environment. But within the chassis I/O modules, what we do is we'll select the new version that we're going to throw onto this system. And the thing that we'll make sure to do again here first is we're going to set the startup version only, which is the default here. And then we'll ignore the compatibility check as we upgrade the software. So what this is actually doing is just saying, next time the chassis I/O modules are rebooted, then upgrade the software. And this will happen when I actually upgrade the fabric interconnects in the UCS, the A side and the B side. So here, the next step, what I'll do is go to the UCS Manager itself, that process that is running highly available between the UCS fabric interconnects, and it shows up as scheduled. Now, since I'm on the UCS Manager process, I expect to be dropped from that process as it does restart on the cluster VIP between the actual nodes. So part of this demonstrates the reasoning or the logic behind the dual fabric design of the UCS. In the access of customer data centers, and we'll quickly show here that the pings are still going through. Nothing has happened yet. I'll bring up a terminal that shows the actual rebooting of the fabric interconnect when the time comes. But right now, since we're just doing a UCS Manager reboot, that's non-service impacting also. But the dual fabrics that are out there in the UCS, think of it as a SAN A and a SAN B, but also a typical customer server instance will have uplinks to redundant Ethernet switches, for example. And so that's a fundamental part of the Cisco UCS design. So we can rely on this system to actually do these upgrades with minimal impact. So on here, when we come into the device, relog back in to the UCS VIP, expand this out, we'll see that the UCS Manager process itself has now been upgraded. And we're still running on the version on the fabric interconnects. Again, we looked at the pings here. Everything's up and humming right along. not too terribly exciting, as we've not done anything to either data plane to the server. But that's actually what we're going to do now. So as we break out the actual fabric interconnects themselves, we'll choose the subordinate. So this is the one that's not hosting the VIP, the cluster VIP for the UCS Manager process. I will select the upgrade software version here, ignore the compatibility check again, and I'll apply that to the infrastructure. So when I apply that right here, I get the authorization, or I give it the authorization to go ahead, and it starts the process. So here's where I'm showing, I fast forward basically to the actual terminal server that shows the screen messages scrolling out of the fabric interconnect to say I'm rebooting. Now we lost KVM connectivity there because we were going through that device, and so the KVM into the blade we reestablished through the surviving fabric interconnect, again with no impact, or I guess very little impact on the data plane, because here what we're actually doing is a forwarding path. One of the two silos, in this case the A, is now rebooting, and it's bringing the subordinate fabric extenders along with it. So our traffic has all failed over again below the OS layer in the Windows and Linux. They would not even see an outage, and the time frame, the timeout on those pings is set too high right now to detect any kind of an outage. And then we see the same thing on the virtualization side. So now we'll jump into the next step, and we see that our A side has been upgraded. Obviously I've skipped ahead a little bit in time here just to respect the viewer's time. And on the B side, this is our primary now, and we're going to do the same thing. We do the upgrade, but this is the device that's actually hosting the VIP that we're using, and again that we're logged in. So now it's going to queue a change, and we jump back to the host again, look at the ping scrolling through, and as we look, we see that the box is rebooted, and I've gone back to my jump box where I'm running my application. I need to re-log in to UCS Manager again. So this again was probably about a 7-minute process actually to come back into the box. And you'll see this B side is still rebooting. Okay, it's still coming back up, or activating right here. But we're back in now on the other fabric interconnect, ready to manage the system. Again, when we look at the servers, reopen the KVMs now, we see that no data traffic has been missing across these various service offerings within there. So I've got to log back in again, and we see the continuous pings going forward on these servers. This represents actually what would probably happen in two change windows. The first one would be just upgrading the A-side fabric. In an entirely separate change window would be the B-side fabric, typically anyway. Now what we could do is expand this out, and we see on the infrastructure everything has been now modified and upgraded. Again, this is what represents the infrastructure bundle. What would be upgraded from a common UCS baseline perspective. As I look inside the servers, you'll see there's firmware that could be upgraded, or that needs to be upgraded if our apps call for that. And the way we do that in the x86 architecture, to actually upgrade image, BIOS or RAID controllers or option ROMs, things like that, that does require an outage of the server itself, of course. So what we do here is maybe rely on VMware DRS technology in this example, where I'll go and put servers in maintenance mode. So I put one in, I'll jump to another server here that I want to apply this new software version, firmware version to the blade, and I put the server in maintenance mode. Now I've migrated machines off ahead of time, so it makes it much faster to drop in and out for the purpose of the demo into maintenance mode. When I jump on the server that has been put into maintenance mode, I can take a look and say, here's the profile that I'm interested in right here. This that's the server that was hosting that VMware ESX instance. I can go to the firmware policy right now and see, I had a firmware policy set. Now either I can create a whole new one or use the one that's here. So here I'm just going to go modify the existing firmware policy. How I choose to do this right now Now I go down the adapter tab, all of the different adapter firmware. Look at the next tab, all of the different BIOS firmware on a given bladed infrastructure, filling out this package, and the impact that it will have by changing these. The board controllers, these are the CPLDs that are on all vendor motherboards. The FC adapters, the native FC side of the house, the HBA option, some of these things, and then lastly the storage controllers that are on the various platforms in the infrastructure. When it detects and finds a certain platform, we can set the versions. Now I've just chosen to set a version on everything, but by an app, basically this maps close to trying to have a golden build. Now I've affected the change here. You'll see there's pending activity flashing up there, and I'm hovering over the reboot now. That's my maintenance policy. Here I said queue the change. Okay. Now since I've already put my server into maintenance mode, I can just go ahead and reboot right now. Otherwise, I could leave all this, no data plane impact to the server is going on until I tell it to do it, or I can set a maintenance schedule here. So you'll see the server is not reachable right now from vCenter as it's getting its new firmware builds coming back up, etc. And you see the update being shown as in progress right here. And that's the process to actually do some of the upgrade with high availability. To recap, doing the day-to-day, the administration, maintaining software versions, firmware versions, all that, really impedes a high degree of automation and stateless design. The UCS has significant advantages in doing this, and we attempted to show that in this video. This ends this UCS Advantage video where we show how unique capabilities of the Cisco UCS can lead to simplified deployment models. Please go to www.cisco.com for more information. Thank you.